Partitions of a set. Partitions of a set A is simply non-empty subsets and non-overlapping subsets of A. What this means is that if we take a set A and we want to partition it, we generate non-empty subsets and non-overlapping subsets of A. So some partitions of A, 1 for AI. Let's say AI is among the partitions of A, it means AI is not an empty set. And 2, AI intersection AJ must be equal to the empty set whenever I is not equal to J. What it means is that all the partition sets should not overlap. In other words to say, there should be no intersection. And lastly, when we take the union of all the partitions of A, we should get A back. So A1 union A2 to AN should certainly give us the set A. These are the three conditions for partitioning a set. Don't worry if you don't understand this at the moment. Let's take an example and you would appreciate this concept. Assuming my set A is equal to A, B, C, and I want to partition this set, I would write a certain number of non-empty subsets of A, and these subsets must not overlap. It means they shouldn't intersect. So the first example I can write is a set containing A, B, and C. You would realize that each of these is not an empty set and they don't intersect or overlap. Also, when we take the union of these three sets, we get our set A back. The second example, we can have A, B, and C. This is also another partition of the set A. You see, the sets are not empty, they don't overlap, and when we put all together, that is when we take the union of it, we get our set A. 3. Another one we can do is that we can take A, C, and B. This is also another partition from the set A, and clearly it obeys the three conditions, which says that AI must not be an empty set and AI intersection AJ must be an empty set whenever I is not equal to J. And lastly, when we take the union of all of them, we should get the set A. If these three conditions hold, then it means that these are proper partitions. So go ahead as trial for yourself. List other two partitions from this set. Go ahead and try this. You may leave your answer in the comment section below. Now, in the concept of power sets, we saw that if we have a set A, the power set of A, let's say if the order of A is n, the power set of A also has an order 2 to the power n. How about partitions? Well, for partitions, we don't have a well-defined formula to calculate the number of unique partitions we can generate. Just that if you have a set of order 2, you can have 2 partitions. If you have 3, and then you'll be getting 5 partitions. And for 4, you get 15 partitions. 5, you get 52, and so on and so forth. The number of partitions grows rapidly, so there is no a specific formula for calculating it. Okay, maybe as a challenge to you, write 3 partitions of the set. You can pause the video and try your best to solve this question. I'm saying 3 partitions. So partition number 1, I can write A. I just write the individual elements. This is one partition. 2, I can do A1. You may go ahead and list some more partitions. Now, here is the catch. If you are writing a partition of a particular set, if you form the first set, in this example, I wrote A. The moment you write the element in the set, assume that it does not exist anymore in the set, just so that you don't repeat it. For instance, after writing A, I assume that A is no longer in the set. After writing 1, I assume that 1 is no longer in the set, and so on and so forth. In the second example, I wrote A1, so I assume that A1 is no longer in the set. I wrote 2, I assume that 2 is no longer in the set. In the third example, I wrote A2, so I assume that A and 2 is no longer in the set, so that you do not repeat them. Now, mind you, if you are to write 3 distinct partitions of this set S, and you write this example, and you go ahead to write another example, like say, another example, say 1, 2, 3, A. This is equal to that. So the partitions, these 2 partitions are the same. You are to write unique partitions. So these are the correct answers you should provide. Lest I forget, every set itself is one partition of itself. For instance, if I have a set A equal to A, B, C, and D, One partition I could get from this is the entire set A, B, C, D. And I don't write any other thing again. And you see that this is called the trivial partition. This is trivial. It's literally just like you're writing the same set.